Space, it's vast, mysterious, and full of wonders we can barely begin to understand. Today, we're diving into 10 mind-blowing facts about space that will leave you in awe of the universe. So buckle up and let's blast off.
Let's kick things off with something that dwarfs our entire galaxy, the Hercules Corona Borealis Great Wall. Imagine a cosmic wall stretching for 10 billion light-years across the cosmos. The light we see from the farthest reaches of this wall began its journey when the universe was still in its infancy. It's a humbling reminder of the vastness of the cosmos and the incredible scales on which the universe truly operates.
Time, as we experience it here on Earth, is a constant, reliable companion. But venture out into the cosmos, and you'll find that time itself can become a source of wonder and bewilderment. Take Venus, our closest planetary neighbor, for example. On Venus, a day actually lasts longer than its entire year. Venus spins so slowly on its axis that one full rotation takes 243 Earth days, while it completes an orbit in just 225 Earth days. So if you lived on Venus, you'd celebrate your birthday before the next sunrise.
For centuries, diamonds have captivated us with their brilliance and rarity. But what if I told you there's a planet out there that makes even the Hope Diamond look like a tiny speck of dust? Let me introduce you to 55 Cancri E. This exoplanet, twice the size of Earth, is believed to be made largely of pure crystallized carbon. Under immense pressure and heat, carbon atoms bond to form a vast planet-sized diamond. With surface temperatures soaring to over 3,900 degrees Fahrenheit, it's hot enough to melt even the most resilient spacecraft.
In the realm of science fiction, space battles rage with deafening explosions and the roar of starships streaking through the void. But in reality, the universe is a much quieter place, eerily silent, in fact. Sound, as we know it, is a vibration that travels through a medium like air or water. But in the vacuum of space, there is no such medium. So if you found yourself floating in space, you wouldn't hear a single sound, not even your own heartbeat. This profound silence adds to the mystery and wonder of space.
When we look up at the stars, we're not just seeing points of light scattered across the night sky. We're looking back in time, witnessing light that has traveled for millions, even billions of years to reach our eyes. Now let me introduce you to GNZ 11, the farthest known galaxy from Earth. This faint smudge of light is located 13.4 billion light-years away. The light we see from GNZ 11 began its journey when the universe was just 400 million years after the Big Bang. By studying this ancient light, astronomers can piece together clues about the early universe. Imagine a teaspoon of sugar, an everyday object. Now imagine that same teaspoon, but instead of sugar, it's filled with the material from a neutron star. That teaspoon would weigh about 6 billion tons, roughly the same as Mount Everest. Neutron stars are the collapsed cores of massive stars that have exploded as supernovae. They're incredibly small, typically only about 12 miles across, but they pack the mass of our sun, or even more, into that tiny space. These bizarre objects are essentially giant atomic nuclei, held together by the most powerful forces in the universe. Have you ever walked along a beach, mesmerized by the vastness of the ocean and the countless grains of sand beneath your feet? Now try to imagine counting every single grain of sand on every beach on Earth. But here's the mind-blowing part. There are more stars in the observable universe than all the grains of sand on all the beaches on Earth. Astronomers estimate that there are roughly 100 billion stars in an average galaxy, and there are trillions of galaxies in the observable universe. So we're talking about a number with 22 zeros after it, and keep in mind, that's just the observable universe. Black holes, those cosmic monsters that lurk in the hearts of galaxies, are among the most fascinating and mysterious objects in the universe. They warp the very fabric of space-time, creating a gravitational pull that seems like the epitome of permanence. Their gravitational pull is so strong that nothing, not even light, can escape their grasp, making them appear invincible. But even black holes, it turns out, aren't eternal. They are not immune to the passage of time. They have a life cycle, and eventually they too must meet their demise, just like stars and other celestial bodies. Stephen Hawking discovered that black holes emit a faint radiation, now known as Hawking radiation, due to quantum effects near their event horizons. This was a groundbreaking revelation. This radiation carries away a tiny amount of the black hole's mass over time, causing it to slowly evaporate, a process that can take eons. Even the most seemingly indestructible objects in the universe are subject to the relentless march of time and the unyielding laws of physics, reminding us of the transient nature of everything. We've talked about the vast distances of space, the incredible density of neutron stars, and the mind-boggling temperatures of diamond planets, which can reach thousands of degrees. But what about the coldest place in the universe? Have you ever wondered where it might be? Where is the cosmic refrigerator located? Let's take a closer look. The coldest known place in the universe is right here in our own Milky Way galaxy, just 5,000 light-years away from us. It's called the Boomerang Nebula, a planetary nebula, a cloud of gas and dust shed by a dying star, creating a stunning cosmic spectacle. The gas cools to an astonishing negative 458 degrees Fahrenheit, or just 1 degree Kelvin above absolute zero, the theoretical limit of cold. The Boomerang Nebula makes even the most frigid places on our planet seem balmy by comparison, a true marvel of the cosmos. One of the fundamental tenets of Einstein's theory of special relativity is that nothing can travel faster than the speed of light. This principle has been a cornerstone of modern physics for over a century. It's a cosmic speed limit, a barrier that seemingly can't be broken. The speed of light, approximately 299,792 kilometers per second, is the ultimate speed limit in the universe. But while nothing can travel through space faster than light, space itself isn't bound by the same rules. Space itself can expand faster than the speed of light, defying this cosmic speed limit. Space can expand faster than the speed of light. This phenomenon is known as cosmic inflation. The universe is expanding, and it's doing so at an accelerating rate. This means that the distances between galaxies are increasing over time. Distant galaxies are receding from us, and the farther away they are, the faster they're moving. This is a direct consequence of the universe's expansion. At a certain distance, known as the Hubble horizon, galaxies are moving away from us faster than the speed of light. This creates a boundary beyond which we cannot see. This cosmic expansion has profound implications for our understanding of the universe. It challenges our perceptions of space, time, and the very nature of reality itself.